So good morning friends. In continuation of the last video where I have just given some introduction about photochemistry. Now in this video I am just going to explain one of the phenomena that is observed and which is nothing but photosensitization. But before understanding photosensitization, what happens when a molecule absorbs radiation, that is light radiation, which exists in the wavelength region of UV visible, that is 200 to 800 nanometers. So what happens now? Let us try to understand. Before that, we should even know that within a molecule there will be different types of energy levels. So electronic energy levels, vibrational energy levels and rotational energy levels. Out of these three energy levels, the energy gap that is existing in between the two electronic energy levels will be very high, and within each electronic energy level there will be presence of vibrational energy levels and rotational energy levels. So now when light radiation of wavelength range which is in between UV and visible radiation falls on a particular molecule, then the molecule which is present in the ground state, it will absorb the light radiation in the form of photons and it undergoes excitation. So this is the picture which is giving clear information about or showing the information about the excitation of a molecule from the ground state to the excited state. So these are the photons. So because of the photons, now the molecule is undergoing excitation because of the photons it is gaining some energy, and because of that it is undergoing promotion from ground state to higher energy level, that is which we call it as excited state. So in photochemistry we deal with such type of electronic transitions. So photochemistry is a branch of physical chemistry which mainly deals with the electronic transitions that occur within the molecule. So here by the absorption of light radiation it will gain energy. So this is the photons which are seen to be falling on the molecule, thereby it is getting promoted into the excited state. So by the gain of energy it is getting promoted to the excited state. So now this is what we discuss in photochemistry. Now because the molecule is absorbing radiation, now again it won't reside in the excited state for a long time, it will come back to the ground state. So there are several phenomena through which it will come back to the ground state. So what are those phenomena that can be understood from one more diagram? So this is the diagram which gives us information about the comeback of the excited molecule from higher energy levels. So if you see this picture, some terminology is present: S0, S1 and T1. So what is S0, what is S1 and what is T1? So let us try to understand this. S0, S term corresponds to singlet state and T term corresponds to triplet state. S0, S1, it corresponds to two different electronic energy levels. S0 is the electronic level, that is ground state, and S1 is nothing but electronic state, excited state, and T1 corresponds to triplet state. And since T is having a subscript of 1, it indicates that it is excited state and it is the triplet excited state. Now what is the difference between singlet state and triplet state? So when do we call a state as singlet state? When the S value, spin value is 0, when you calculate by taking the spin value equal to 0, the spin multiplicity becomes equal to 1, and that state is known as what? Singlet state. And if you take the spin value as 1 and if you calculate the spin multiplicity, then you will be getting 2s plus 1 is the spin multiplicity formula. So if you calculate the spin multiplicity, it will be equal to 3. So for a state, if the spin multiplicity value is 1, then it is known as what? Singlet state. And if the spin multiplicity is 3, then we get the triplet state. So for every molecule there is an equal possibility of singlet excited state and triplet excited state. So this is the pictorial representation of the possible singlet excited states in the molecule and triplet excited state. So now what is this diagram giving us information? So this diagram is showing that when a molecule is present in the ground state, so by the absorption of radiation, it is getting promoted to higher energy levels, and that energy level is known as what? Singlet excited state. So after undergoing excitation, as I have stated, now it will be coming back through various phenomena. The phenomena may be radiative or non-radiative. Radiative in the sense they will come back by the emission of radiation. Non-radiative means they will come back to the ground state but by not emitting the radiation but by the dissipation of heat. So such phenomena are said to be radiative processes and non-radiative processes. So radiative processes are those wherein the excited molecule comes back to the ground state by the emission of radiation, and non-radiative processes are nothing but those wherein the molecule comes back to the ground state just by the dissipation of heat. So this picture is a mixture of both radiative and non-radiative processes. And one more thing what you have to observe here is there are curved arrows as well as there are straight arrows. So curved arrows represent non-radiative transitions and straight arrows represent radiative transitions. So if how many curved arrows you are seeing here? 1, 2 and 3. So what are these curved arrows? Now let us see. So first curved arrow is labeled as vibrational relaxation. So what is the meaning of vibrational relaxation? When the molecule comes back from one vibrational energy level to another vibrational energy level just by giving out heat, then that is known as what? Vibrational relaxation. So here it doesn't undergo any radiative transition, it just comes back just by giving out the heat. And there is one more non-radiative transition which is called as intersystem crossing. So what is this intersystem crossing? Molecule which is present here is coming back from singlet excited state to triplet excited state by giving out heat. So when a molecule jumps from singlet excited state to triplet excited state by the dissipation of heat, then that is known as intersystem crossing. In between two states it is undergoing crossing, so thereby it is known as intersystem crossing. So vibrational relaxation and intersystem crossing are non-radiative processes. Suppose if you see here there is a strong arrow mark, and here this is also one more strong arrow that is represented. So what is this? Now when a molecule comes back from singlet excited state to singlet ground state by the emission of radiation, then that is known as what? Fluorescence phenomena. As I said, these strong arrows or straight arrows represent radiative processes. So here it is coming back from here to here by the emission of radiation, so that is known as fluorescence. And when a molecule comes back from triplet excited state to singlet ground state, then that is known as what? Phosphorescence phenomena. Triplet to singlet is known as phosphorescence, singlet to singlet is known as fluorescence phenomena. So fluorescence and phosphorescence, both of them are radiative processes. So in this picture we can see how many radiative processes? 2 radiative processes. And how many non-radiative processes? 2 non-radiative processes. One is vibrational relaxation and another one is intersystem crossing. So here, so this is fluorescence, and if you see this is intersystem crossing, and this is nothing but the phosphorescence phenomena. And there is one more phenomena that is observed, and that is known as photosensitization. So what is photosensitization? If you what is photosensitization? In general, what we can understand is during a reaction, if one of the reactant absorbs the light radiation and transfers the energy that is associated with it to another reactant molecules to facilitate the reaction. Then such a type of reactions are known as photosensitized reactions, and the phenomena is known as photosensitization. So the substance which is absorbing the radiation is known as photosensitizer. So the phenomena which occur in the presence of photosensitizer is known as photosensitization. So what actually happens in photosensitization can be understood from this particular diagram. So what is this diagram giving us information? So as I said, there will be energy transfer. So how the energy transfer occurs can be understood from this particular diagram. So here, as we have discussed, when a molecule absorbs radiation, it gets promoted from singlet state, ground state, to singlet excited state. So from singlet excited state, now, so from singlet excited state, it undergoes intersystem crossing to the lower energy states. So here the molecule is undergoing intersystem crossing and is changing into the triplet excited state. So here what is happening in the initial stages? The molecule which is present in the singlet ground state is absorbing radiation and is getting promoted to the singlet excited state. From there, through intersystem crossing, it is coming to the triplet excited state. So in this triplet excited state, it interacts with another reactant molecule and transfers its energy. So because of the transfer of energy, now the molecule which is present here, it is gaining energy and is getting excited to one more energy level. So here, this is an example where you can see here the transfer of energy in between the excited molecule as well as another molecule. So here there is a transfer of energy in between this molecule and the oxygen molecule, and here by the transfer of energy, the oxygen molecule which is present in the triplet excited state is changing into singlet excited state. So by the gain of energy from triplet excited state, it is changing into singlet excited state. So here this step is nothing but transfer of energy from this molecule to this molecule. So upon transferring its energy, now it will come back to the ground state. So here in this picture what we are able to see, a molecule undergoing absorption of light radiation, undergoing excitation to singlet excited state. So from the singlet excited state, it is undergoing some internal conversion within the state, and from that it is through intersystem crossing, it is changing into triplet excited state. In the triplet excited state, it is exchanging energy with another reactant molecule which is present. Thereby that molecule is also undergoing excitation. So now this participates in the reaction and this is coming back to the ground state. So this phenomena is known as what? Photosensitization. The substance which is transferring the energy. So this part is nothing but the substance which is absorbing radiation and it's transferring energy. So that is known as photosensitizer. So photosensitizer is initiating the formation of singlet oxygen here, which further participates in the reaction, and so this is nothing but photosensitization. To understand in a better way, a good example is the photosynthesis phenomena. So in photosynthesis, what happens? The plants, they prepare the food material, giving out the oxygen. But this photosynthesis phenomena takes place in the presence of a molecule, chlorophyll. So chlorophyll here acts as a photosensitizer. It will absorb the light radiation, and that energy that is associated with that light radiation is given to the carbon dioxide, which facilitates this particular reaction, resulting in the liberation of oxygen. So photosynthesis is a phenomena, nothing but photosensitization phenomena which is observed in the nature. So this is what about today's video. That is what we have learned. What happens to the molecule when it undergoes absorption of light radiation, and then what are the various phenomena, that is radiative and non-radiative phenomena, and what is photosensitization and how the transfer of energy occurs.